Welcome to ClickMyProject.com.
Now we discuss about the product for information hiding as a challenge for malware detection. Next, we see the abstract for the product. Steganography, analogous to the data hiding, aims to hide the secret information under digital media in such a way that no one apart from the sender and receiver can detect existence of the information. In recent years, many data hiding methods have been developed for binary images, which can be used to authenticate digitally stored handwriting, CAD graphs, signature, and so on. Stereo images obtained by these schemes have also been reported to achieve considerable visual qualities. However, these methods ignore the security against technologies, the high undetectability of secret message can reduce the suspicion from attacks, and these enhance the security. To this end, we focus on designing a secure binary image data hiding scheme, or more strictly speaking, and the steganographic scheme, by improving the undetectability while preserving the stegno image quality and the embedding capacity. In the spatial domain, message bits are commonly embedded to direct flipping pixel value in a binary image. Unlike the grayscale image, pixel in a binary image process only the two stacks, black and white. More state-of-art binary image steganographic technique only consider the flipping distortion order according to the human visual system, which will be not secure when they are attacked by steganolizer. In this paper, a binary image steganographic scheme that aims to minimize the embedding distortion on the texture is presented. We extract the complement, rotation, and mirroring invariant local texture pattern from the binary image first. The weighted sum of Creme LTP changes when flipping one pixel is then employed to measure the flipping distortion corresponding to the pixel. By testing on the both symbol binary image and the constructed image dataset, we show that the proposed measurement can well describe the distortion on both visual quality and statistics. Based on the proposed measurement, a practical steganographic scheme is by dividing the scrambled image into superpixel. Therefore, after the syndrome release code is employed to minimize the designed embedding the distortion of the or result of demonstrated, the proposed steganographic scheme can be achieved to statistical security without degrading the image quality of the embedded capacity.
Next, we see the flow diagram for the product. This is the flow diagram for our encryption data embedding based steganography process. This is the secret message to be passed in our the AES encryption architecture, and the key data bits also embed in the AES encryption. This AES encryption architecture inbuilt presence consists of the shifted rows, mixed columns, add round key, all the components to be present in the AES architecture. We use the 4 round based key for the secret message, and they apply key data bits. Then to passing the embedded sequence to be passed in the LSP technique. The LSP technique to be embed the selected image to encryption data bits. The encryption data bits and the image to be passing in the LSP technique. The least significant bit technique to be embed the cover image and the encryption data. This is the overall final output to be passed in the encrypted image with the encrypted data. The encrypted image to be it's look like a same covered image. So the encryption data to be add the LSP based technique in the 3-band level. The R and GB, the 3-band to be embedded for the encrypted data with the embedded image. This is the sender side for our steganography process, and the receiver side to collect the embedded image and to split the R and GB 3-band and apply the LSP technique. The LSP to split the cover image data and the encrypted message data. So whenever the encryption key to be applied the AES decryption process and to retrieve the secret image finally. This is the receiver side process for our overall steganography process. This is the final flow diagram for sender and receiver side based steganography architecture. This is the final output for the product.
First we run the MATLAB function for apply the input and selected image based process. Just to run the process, so apply the input data bit, any of the input data to be apply, and any of the key data for the AES encryption process. Then to select the any cover image, then these all the data to be retrieved and to write in the numerical value in any one of the text format. Then we open the Xilinx process and to receive all the things and to process one by one. First we process the Xilinx oriented process for AES encryption architecture. So we go to the Xilinx oriented process for AES encryption architecture. So then to open the AES encryption code, then to open the Xilinx AES project navigator. This navigator to be passed in the encryption based architecture, AES encryption architecture. We use the 4-round key for our encryption based process. Then the encryption architecture to select and simulate the simulate model. These data to retrieve the input data and key data and to create the encrypted data for our overall architecture process. These are the encrypted data for our required input message. Then the close and open the embedding process. Just to open the steganography embed process, select and run the steganography embedding process. Then to select embed work and to run the embedding based process. Then completed the embed steganography embedding process. Then to close and to open the steganography retrieval process. These two are the encode and the embed is a center side, and the steganography retrieval and decryption code and final output data for the receiver side. So just to open the steganography retrieval process. This retrieval process to retrieve the original information and cover image also things. This is the retrieved information. So this is the retrieved decrypted image. Then the decryption AES decryption process to be run. Apply the same key data and to decrypt all the informations and to get the final output data bits. Then to close the overall data bits and close all the things. Then to get the final output data bits. These are the final output data bit for overall input information. So the input information is to print the all the things. Just you select the clocking signal. So initially apply the clock, then to apply the one based process, then to run, and finally we get the input data. These are the overall steganography based process for our output image based process. Then to retrieve the cover these are the encrypted image for our overall architecture. These are the encrypted image. These are the retrieved output data bits.